Hello. So I'm going to start with a video recording. This is going to be our first lesson in algebra symmetry for our first unit of pre-calculus. So we're going to discuss today about even and odd functions, about their symmetry, both graphically and algebraically. So first of all, let's just look at it graphically. I'm just going to give you the quick lowdown on this so you understand what's going on, and then we'll talk about it further in class together. So, an odd function here, its graph is symmetric with respect to the origin. I guess you all know what the origin is. Here's the origin, 0, 0, 0, 0, 0, 0, and those three graphs. So if it's an odd function, if it has odd symmetry, the coordinates, the xy coordinates change from a, b to negative a, negative b. Now I know you can read that and you're probably going, what the heck? All right, so this is what I want you to think of. Think of the negative as opposite. So if you have any x and y coordinate, do you have the opposite x and the opposite y on the graph? Okay, so we're going to do an example here in 1 second. Let's do it for the even function, same idea. An even function has even symmetry. It will be symmetrical around the y-axis. Okay, so this one's symmetrical, odds are symmetrical about the origin, even symmetrical about the y-axis. So an even function, if you have a coordinate, any xy coordinate, you should expect to see the opposite x but the same exact y. All right, so think about that negative as opposite. So any xy coordinate, you should see the opposite x coordinate but the same y on the graph. So you're going to have neither of those cases going on. Okay, so here you can see graphically this looks like, and I'm going to give you a little bit better example here in 1 second. This looks like it's symmetrical around the origin. This one looks like it's symmetrical around the y-axis. Okay, and that has neither of those two cases. So let's look at an example here. I'm going to show you up close. Let's look at this function right here. Right away you might tell that it's symmetrical around the y-axis, so that's a good sign already. Here's what I want to show you with those coordinates. For whatever x and y coordinate you see, you should see the opposite x with the same exact y. So if I take this coordinate here, 1, negative 2, right? 1 on the x, down 2 here. Just pretend, okay, that I have a perfect graph here. Do you see the opposite x with the same y? Do you see what's the opposite of 1? Negative 1. Do you see the same y? Are the y's the same, but are the x's opposite? See what I'm saying? Okay, let's do it for the odd graph. For an odd, whatever input you have, you should have the opposite x and the opposite y. So let's look here. If you have this xy coordinate, do you see the opposite x on that graph and the opposite y? So 1 goes to negative 1 and negative 2 goes to 2. Do you see how opposite is easier than thinking negative and positive? So if you have a 1, you see the opposite, which is negative 1. If you have a negative 2, you see the opposite, which is 2. So that would be odd symmetry. Okay, what I want to make sure that you do is please copy these examples that I'm giving you in your notes. This is going to help you. This is going to help you decipher anything that you're doing with your math. Okay, I want you to copy those notes down that we just did right here and everything that I'm showing you on here. Okay, so this part here, I'm going to let you do these on your own. We might go over them really quickly. If you have any question, please ask me on any of these in class, okay? If we don't have time to go through them. I want you to know on these notes, you have here the answers right afterwards, but you need to know this backwards and forwards. You need to be able to do this, okay, on your test and your quiz. You need to know how to check if they're even, odd, or neither. Okay? We'll do this in class. Here's that. Now, part 2, moving on very quickly. we are going to be able to check if a function is even, odd, or neither algebraically, meaning not looking at the graph, but looking at a function and using algebra. All right, so we're going to do the same thing here. If you have a function, if you input, this is your input in here, if you input a negative x, if you get out, again, think of it as opposite, okay? If you input a negative x, what you should get out of it is the opposite of your original function, okay? So if you put in a negative x in there, your function should be exactly the opposite of your original function, okay? If you put in a negative x, and then it would be an odd function. If you input a negative x and you get exactly the same function as you started with, then you have an even function, okay? All right, so I have some notes here. Please write this down on your notebook. So again, this is where your input goes. If you input a negative x into your whole function, into your algebraic function, like y f of x equals x squared. If you put in a negative x, see if this is your function right here, x squared, y equals x squared, and you input a negative x into that, what are you going to get? Negative x times negative x equals x squared. Okay, this is your original function. You input a negative x and you're getting also an x squared. What kind of function is that going to be? It's going to be even. If you input a negative x and you come out with exactly the same as your original function, then you have an even function. If you input a negative x and you get the opposite of your original function, then you have a odd function. If you get neither of those two cases, exactly the same or exactly opposite, then you have neither even or odd symmetry. All right, good. So I'm going to change pages here. Okay, so here, I'm going to test it. These are examples that should be on your paper here. That's your next page of the notes here that I gave you. I'm doing the top three right there, okay? We're going to test these functions. So I'm going to give you the easy shortcut way on how to do this. Instead of using a negative x, I want you to pick a number, but a good number, not 0 or 1, something that's like, you know, you're going to come up with the same answer that you started with no matter what you have. Pick a number like -3 or -4, something not too difficult, but not a stupid number like 0 that you're always going to get 0 for an answer. Pick a negative number and test it against the opposite. So 3 and -3, okay? So we're going to do the first function here, x squared minus 5. If you put -3 in that function, that would be, right, -3 squared minus 5. -3 squared is -3 times -3, which is 9. 9 minus 5 equals 4, okay? What if I do the opposite? So -3 and 3, we're going to compare. 3 squared minus 5. You input 3 now. 3 times 3 is 9 minus 5. You also get 4. If your two answers are exactly the same number, you have an even function. Okay, this is the easy way of doing this. I'm showing you the easy way. Okay? Next, let's do the next function, x cubed minus 3. Let's do the same two numbers, -3 and +3. If you input -3 into your function, -3 cubed minus 1, that would be -3 times -3 times -3, which equals -27, minus 1 equals -28. Compare it to, right, the two opposite numbers here, positive and negative. F of 3. 3 cubed minus 1 equals 3 times 3 times 3 is 27, minus 1 equals 26. Are these two numbers exactly the same? No. Are they exactly opposite? No. So what do you have? You have neither even or odd symmetry. Okay? And let's try the one last function here. This one up here, x cubed plus x. So f of x equals x cubed plus x. Let's do our two opposite numbers, plus or minus 3. You could do plus or minus 4 if you want to, plus or minus 5 if you want to, whatever. They should have the same type of result, even, odd, or neither symmetry. Okay? So x cubed, the negative 3 cubed, plus x, put in a negative 3. Everywhere you have an x, you put in negative 3. That's your input. Everywhere you see x, you put in negative 3. Okay? Negative 3 cubed is negative 27, plus a negative 3 would give you negative 30. Okay, let's do the opposite, which is positive 3. Put in 3 everywhere you see an x. 3 cubed plus 3 equals 3 times 3 times 3 is 27, plus 3 equals 30. What do you see about those two results? They are exactly the opposite. So here you have an odd symmetry function. Okay. So straightforward. All right, sorry. Here, this is quick here. So I'm going to leave you to do, and notice this, all the answers are here, they're worked out for you. Go through all these examples, all right? This should be easily decipherable now. Okay, power functions. You have to know what a power function is. A power function in shortcut only has a single term. Now that should be easy if you know what a term is. What is a term? Terms are separated by plus and minus signs. So if you have this, 2x to the 6 minus 3x minus 5, here's the minus signs. One term, a second term, a third term. This has 3 terms. Is that a power function? Power function has one term. Is it power function? No. How about this one? How many terms do you see? Do you see how many plus or minus signs do you see going on there? Just one term. 2 terms. One term. One term. 1, 2, 3 terms. 2 terms. Okay? Short and easy. All right, now, this practice is included in your notes. You need to know how to do this. I'm not kidding. You have to do this, okay? So I'm going to do this one piece right here. We'll discuss some of the other ones. True or false? This point A, which is negative 3, 6, is on the graph of this function right here. Explain your reasoning. What if you had no calculator? You need to develop the critical thinking. How would you know that this point is on this function here? What would you think of? This is your x. This is your y. Do you see some x's here? Yes. What is this? F of x is the same as y, right? Y equals f of x. Do you have an x and a y here, and an x and a y here? Yes. So if this point is on here, if you input negative 3 into this function, what should your answer be? What should your y be if this actually is on there? It should be a 6. So let's try it real quickly, right? Here's our function, f of x equals x squared, plus 4x minus 2. Okay, we're going to input negative 3. If we input negative 3 plus 4 times negative 3 minus 2 equals 9 plus a negative 12 minus 2, which equals, what is that? Is that going to be positive 6? No. 9 minus 14, whatever that is. Which is not equal to 6. So is this point on here? No. All right. So here's one more thing I want you to realize. So I want you to work all of these problems out. pay special attention here, please. This box right here, pay special attention to this. All right, that definition there, we're going to go over that in class. It says interval refers to the domain, so it's just another word, interval and domain. Interval, domain, same thing, same thing, same thing. It's just vocabulary. Write it down in your notes. If it's got a big box around it and a star, it's important, okay? Do these problems. It's all worked out for you right here. Do these problems too. This is easy. You should remember this. The vertical line test tells you if you have a function, okay, y equals 5, for example, is a horizontal line, x equals -2 is a vertical line, okay? So vertical line test, how many times should it hit a function? Only once. The line, no matter where you put it, should only hit it one time. So is a circle a function? Look at the circle. Is that a function? No, because it hits it twice anywhere. Okay. All right, that's it. I want you to read your notes, go over them now that you've seen the video, and thank you for listening.